Good day, friends. You are welcome to your favorite learning channel. Today we are going to discuss about another interesting topic in chemistry called balancing of ionic reaction. Balancing of ionic reaction. Then what is ionic reaction? Ionic reaction is also known as redox reaction. Redox reaction. So redox reaction is a chemical reaction whereby oxidation and reduction occur simultaneously. Is a chemical reaction whereby oxidation and reduction occur simultaneously. I've explained oxidation and reduction reaction in one of my past video. So to have access to my past video, kindly subscribe to Royal Learning Channel. Royal Learning Channel. So this morning we are going to discuss about ionic reaction. Ionic reaction. So ionic reaction is divided into two parts. Ionic reaction is divided into two parts. Then the first one is simple ionic reaction, while the second one is complex ionic reaction. Then how will you be able to recognize a simple ionic reaction? Then how will you know a complex ionic reaction? A complex ionic reaction consists of atoms of oxygen. A complex ionic reaction consists of oxygen atom, while a simple ionic reaction do not consist of what? Of oxygen atom. There is no atom of oxygen in simple ionic reaction, where there is what? Atoms of oxygen in complex ionic reaction. So in today's video, we are going to discuss about balancing of simple ionic reaction. We are going to look at balancing of simple ionic reaction. Then I'm going to explain two methods of balancing simple ionic reaction. I'm going to explain two methods. So the first method is called ion electron method. Ion electron method. Then the second method is called oxidation number method. Oxidation number method. So we are going to make use of these two methods in order to balance simple ionic reaction in today's class. Now, let's look at the first equation, example 1. Example 1. So let's look at reaction between ion 2 and chlorine molecule. Reaction between ion 2 and chlorine molecule gives ion 3 plus chlorine ion. Ion 3 and chlorine ion. So reaction between ion 2 and chlorine molecule will give us what? Ion 3 and chlorine ion. So how can we balance this simple ionic reaction? So you can see that in this reaction there is no oxygen atom. No oxygen atom in this reaction. So therefore it is a simple ionic equation. It is a simple ionic equation because there is no oxygen atom. Now, what is the first step to take? What is the first step to take? So the first step to take is to assign oxidation number. You assign oxidation number to each atom. Assign oxidation number to each atom. So what is the oxidation number of ion? The charge on it is the oxidation number of ion. So therefore, the oxidation number of this Fe, which is ion, is what? Is +2. Is +2. So what is the oxidation number of chlorine molecule? Note, the oxidation number of any atom, of a free atom or molecule, is usually equal to 0. The oxidation number of any molecule or a free atom is usually equal to 0. So this is chlorine molecule because it is in form of gas, Cl2. So therefore the oxidation number equal to what? Equal to 0. So the oxidation number of this ion is the charge on it, so which is equal to +3. The oxidation number of chlorine ion is the charge on it. This minus means -1. So therefore the oxidation number equal to what? -1. minus 1. Now, we are going to split this ionic reaction into oxidation, one half oxidation and one half reduction. We are going to split it into oxidation half and reduction half. So we split it into oxidation half. So from there, we'll be able to know the substance that oxidized and we'll be able to know the substance that reduced. Then don't forget that the substance that oxidized is a reducing agent, while the substance that reduced is an oxidizing agent. Now, how are we going to recognize the substance that oxidized? Then what is oxidation? Oxidation is increase in what? In oxidation number. Oxidation reaction is increase in oxidation number. So let's look at iron to iron 2. From iron to iron 2, we have +2 to +3. There is what? Increase in what? In oxidation number from +2 to +3. So therefore, iron 2 undergo what? Oxidation reaction. So iron 2 oxidize to iron 3. So this is oxidation. Then from chlorine to chlorine ion. From chlorine to chlorine ion, that is from 0 to -1. If 0 is more than -1, so from 0 at the reactant side to -1 at the product side. So there is decrease in what? In oxidation number. The reduction is decrease in oxidation number. So this one undergo what? Reduction reaction. Reduction reaction. So therefore now we can split this reaction into oxidation half and reduction half. So for oxidation half, so we have iron 2, which is Fe2 plus to iron 3. That is Fe3 plus. Fe3 plus. The reduction half from chlorine molecule to chlorine ion. Reduction half. So that is from Cl2 to Cl minus. From Cl2 to Cl minus. So the first one, you assign their oxidation number. Assign oxidation number to each atom. Then number 2, split into 2 half reaction, that is oxidation half and reduction half. So after this second step, then the third step, this is the first step, then this is the second step. Now third step, so you balance the number of what? You balance the number of atom in each half reaction. Balance the number of atom in each half reaction. Now, let's write our oxidation half and reduction half. So for oxidation half, we have Fe2 plus to Fe3 plus. Fe2 plus to Fe3 plus. Then for reduction half, we have chlorine molecule to chlorine ion. Chlorine molecule to chlorine ion. So the next stage now, we want to balance the number of atom. We want to balance the number of atom in each half reaction. Now from the first half reaction, we have 1 atom of what? Of iron, Fe. Now the number of charges, their charges does not have anything to do with the number of atoms. So when you are counting the number of atoms, you don't do what? We don't deal with the number of what? We don't deal with the number of charges. So when we are counting the number of atoms. Now, to count the number of atoms, you look at the coefficients of that atom and the subscript. The subscript is what you have at the base. The coefficient and the subscript. Now, the coefficient of this atom is 1. Now the subscript is 1. Invisible subscript is 1. So 1 times 1 is 1. So it shows that we are having one what? Atom of iron at this side. Then at this side too, the coefficient is 1. Then the subscript is what? Is 1. So we're having just one atom of what? Of iron. We don't deal with what? We don't deal with charge. We don't deal with their charges when you are counting the number of atoms. You don't have anything to do with what? Charges when you are counting the number of atoms. Now this one is balanced. This one is a balance because we have one atom of iron at this side. We have one atom of iron at this side. Now let's look at reduction half. Reduction half. At this reduction half, we have one coefficient of chlorine. So chlorine, it has what? Coefficient of 1. The chlorine is having coefficient of 1. So 1 times the subscript, that is 2. So this shows that we are having two what? 2 atoms of chlorine. 2 atoms of chlorine. So we're having 2 atoms of chlorine at the reactant side. Now let's look at the product side. The coefficient is 1. The coefficient is 1. Then the subscript is 1. So this is 1 atom of chlorine. So 1 atom here, then 2 atoms here. So we have 1 atom here, we have 2 atoms here. So we have to balance what? Both sides. So that we have 2 atoms at the reactant side, we have 2 atoms of chlorine at the product side. Now you increase where you have what? Less number of what? Of atom. Where you have lesser number of atoms. So we have 2 at this side, we have 1 at this side. So we put 2 here to balance the number of what? Of chlorine atoms. So we have balanced the number of atoms now. We have balanced the number of atoms. So the next stage is to balance the number of electron loss and the number of electron gain. We balance the number of electron loss and the number of electron gain from each half reaction. Now, how can we do that? So let's write oxidation half. Oxidation half. This O is oxidation, oxidation half. So at that oxidation half, we have Fe 2 plus equal to Fe 3 plus. Fe 2 plus equal to Fe 3 plus. So to balance this oxidation half, so the number of electron at the reactant side is plus 2. The number of electron at the product side is plus 3. So to balance both sides, that is the number of electron at the reactant side must be equal to the number of electron at the product side. The number of electron at the reactant side must be equal to the number of electron at product side. Now, the reactant side, if I take away the reactant side from the product side, that will be 3 minus 2. 3 minus 2, which shows that the product side is 1 greater than the reactant side. The product side is 1 more than the reactant side. Now, to make the reactant side equal to the product side, you add electron to decide with what? With more electron. You add electron to decide with more electron. So therefore, it will now be Fe 2 plus equal to Fe 3 plus. Don't forget that you add electron with the side to decide with more electron. You add electron to decide with more number of electron. So it is 1 greater than what? Than the reactant side. So you are going to add what? 1 electron. Then electron carries us negative charge. It carries negative charge. So adding electron does not mean that you are adding more electron to this, because electron carry what? Negative charge. Now let's see now. This one is plus 2 now. The charge on this one is plus 2. Then the charge on Fe is what? Is plus 3. Then the charge on electron is minus. Now minus times plus will give me minus. Minus multiplied by plus. Plus times minus will give me minus. Then what is the coefficient of this electron? That is 1. So plus 3 minus 1 Plus 3 minus 1 will give me plus 2. So therefore, plus 2 equal to plus 2. So this side now we have 2 electrons, and this side we have 2 electrons at this side. So we have equalized the number of electrons at both sides. So we have equalized the number of electrons because adding 1 electron is like you are taking away 1 electron from these 3 electrons, the 3 electrons that are here. So we have balanced what? Oxidation half. Now let's balance reduction half. Let's balance reduction half. Reduction half. So at the reduction side, we have Cl2 equal to 2Cl minus. Cl2 equal to 2Cl minus. Now, let's write the number of electron or their oxidation number, the oxidation number at both sides. So this one, Cl2 is a molecule, that is, it is a gas, it is a molecule. Then oxidation number of any molecule or free atom equal to 0. So therefore, the oxidation number of Cl2 equal to 0. So another example of molecule is H2. This is a molecule, so oxidation number of H2 will be equal to 0 if it is H2. If it is Fe2, I mean F2. F2 is what? Is a molecule. So the oxidation number will be equal to 0. So oxidation number of any molecule or a free atom is equal to 0. So at this side, let's calculate our oxidation number. That will be the number of charge. That is minus 1. Minus means minus 1. So minus 1 times 2 will give me minus 2. Will give me minus 2. So now we have to equalize the number of electrons now at both sides. We have to equalize the number of electrons at both sides. So the number of electrons at this side must be equal to the number of electrons at the product side. Now, where are we having more electron? 0 is more than minus 2. 0 is more than minus 2. It shows that we have more electron at the what? At the reactant side. 0 is more than minus 2. So we have more electron at the reactant side. So electron will be added. Electron will be added to the side where you have more electron. You add electron with negative charge to the side where you have more what? More electron, or where you have more oxidation number. Now, how many electrons are we going to add to this side? So we are going to say minus 2. That is the reactant, the product side minus the reactant side. So what do we have at the product side? We have what? Minus 2. So it will be minus 2, then minus 0, which is equal to what? Minus 2. So it shows that the what? The reactant side is minus 2 what? Is minus 2 greater than what? The product side. So we are going to add 2 negative electrons to the reactant side. Don't forget that you add electron to the side with more oxidation number. 0 here, minus 2 here. So you add electron to this side. If I say 0 minus 2, 0 minus 2 will give me minus 2. So it shows that we need to add 2 negative electrons to this side. So our half reaction will now be Cl2 gas plus 2 electron, 2 negative electron. So this 2 negative electron is the same thing as minus 2, because minus times plus will give me minus. It will give me minus 2e. Minus 2e. So equal to 2Cl minus. 2Cl minus. So let's calculate the number of electrons at both sides. Let's calculate the number of electrons at both sides. So this one is what? Is 0. Because this is a molecule. So the oxidation number equal to 0. Now this one is minus. Minus 1 times the coefficient. The coefficient is plus 2. Minus 1 times plus 2 will give us minus 2. Minus 1 times plus 2 will give us what? Minus 2. Equal to, the coefficient of this one is 2. Then the charge is minus 1. Minus 1 times 2 will give us minus 2. 0 minus 2 will give us minus 2 equal to minus 2. So we have equalized the number of electrons at both sides. We have equalized the number of electrons at both sides. So what is the next step to take? The next step to take. Let's move to the final stage. Now, before we can combine the two half reactions together, the coefficient of electron from the first half reaction, which is oxidation half, the coefficient of electron from the first half reaction must be equal to the coefficient of electron from the second half reaction. The coefficient of electron from the first half reaction must be equal to the coefficient of electron from the second half reaction. Now, what are we going to do now? We use the coefficient of electron from the reduction half to multiply the equation from the first half reaction. Now, let's bring the two down here. Fe, this is step 4. Let's call this one step 4. So that is Fe 2 plus equal to Fe 3 plus E minus. Now, for reduction half, we have Cl2 equal to 2, Cl2 plus 2E minus plus 2E minus equal to 2Cl minus. So the coefficient of the first half reaction multiplied by the second half reaction. So we are going to use the coefficient of electron here, which is 1, to multiply this one. Then we use the coefficient of this second half reaction here to multiply the first half reaction. Then what will be our product now? So let's open the brackets. You use the coefficient of the second half reaction, electron, the coefficient of electron here to multiply this one. Then you use the coefficient of electron from the first half reaction to multiply the second half reaction. Now let's move to the final stage. Don't forget that we are using ion-electron method. This is ion-electron method. Ion-electron method. Now, this is where we stop. So let's open the brackets now. 2 times Fe2 plus. You multiply these 2 by the coefficient. 2 times Fe2 plus. You are not going to use these 2 to multiply the charge. You only use these 2. That is, these 2 to multiply only the coefficient. So the coefficient of this Fe is 1. So 2 times 1 will give us 2 Fe2 plus. Then this 2 times the coefficient of Fe here, which is equal to 2 Fe3 plus. Then 2 times the coefficient of what? Of this electron, which is 1. So 2 times 1 will give us 2E minus. Now, likewise, we open this bracket by 1. We open this second bracket by 1. So 1 times Cl2 will give us Cl2 gas equal to 1 times 2E minus will give us plus 2E minus. So 1 times this coefficient here will give us what? 2Cl minus. So our equation is balanced from the first half reaction and the second half reaction. Now, this electron from the first half reaction will cancel what? Electron from the second half reaction. Now, we are going to combine the reactant side from the from the first half reaction to the reactant side from the second half reaction. Then we combine the product sides from the two half reactions together. So we combine them together. So from the reactant side there, let's combine the reactant side here together. So at this side, we have 2Fe2 plus, then plus the reactant side from reduction half plus Cl2 gas, then equal to the product side from oxidation half. So the product side is 2Fe3 plus, then plus the product side from reduction half plus 2Cl minus. So this is our product. This is our product. So that is how to use ion electron method to balance ionic equation. Ion electron method. We use ion electron method to balance this chemical equation. So let's take example 2. Example 2. So for that example 2, we are going to use oxidation number method. We are going to use oxidation number method. So we use oxidation number method. So example 2. Example 2. Using what? Oxidation number method. So we want to use oxidation number method to balance example 2. So we have reaction between magnesium and silver ion to give us Mg2 plus Ag. So reaction between Mg plus Ag plus equal to Mg2 plus Ag. So using what? Oxidation number method. Now the first step to take is to assign their oxidation number. So from there, we'll be able to know the substance that oxidized, then we'll be able to know the one that reduced. Now, what is the oxidation number of Mg? Mg is a free atom. This is an atom, so it is a free atom. The oxidation number will be equal to 0. Don't forget that I said that oxidation number of a free atom or molecule is equal to 0. Then the charge on this one will be the oxidation number. So we have plus. Plus is the same thing as what? Plus 1. So the charge on this is plus 1. Then the oxidation number of magnesium here is plus 2. That is the charge on it. Then this one is a free atom. It has no charge. The oxidation number will be equal to 0. So the oxidation number of that one is equal to 0. So what is the next step to take? The next step to take is to balance the number of atoms. You balance the number of atoms at both sides. So balance the number of atoms at both sides. So this oxidation number method, you are not going to separate your ionic equation into one half oxidation and one half reduction. No, it is only ion electron method that you split your equation into one half oxidation and one half reduction. But this oxidation number method, you don't split your equation into one half oxidation and half reduction. Now, the next stage now, we balance our what? We balance out the number of atoms. We are going to balance the number of atoms at both sides. Then don't forget that the charge, their charge does not have anything to do with what? The number of atom, balancing of what? Of atoms. So let's look at magnesium at this side. We have one atom of magnesium because the coefficient of magnesium is 1. Then the subscript is 1. The subscript is the base. So 1 times 1 is 1. So magnesium is 1. So we have one atom of magnesium at this side. Now let's check this side. We don't have anything to do with what? With the number of charge when we are balancing the number of atom. Now the coefficient here is 1. The coefficient here is 1. So we have one atom of magnesium. So magnesium balanced. So let's look at silver, Ag. So we have one coefficient here, then the subscript is 1. 1 times 1 will give us 1. So the number of Ag here is what? 1. So we have one atom of Ag. Then at this side too, we have one atom of Ag. So our equation is balanced. Our equation is balanced. So what is the second stage? The next step to take. Now we are not going to subtract the oxidation number of what? Of each atom. We subtract the oxidation number of the reactant side from the product side. We subtract the oxidation number of atom from the reactant side from the what? From the product side. So the first one is oxidation number of the first atom is what? Magnesium. So what will be the oxidation number of magnesium? That is the product side. Magnesium is at the product, so the magnesium at the product side minus the oxidation number at the reactant side. The oxidation number of magnesium at the product side minus the oxidation number of magnesium at the reactant side. So which is plus 2 minus what we have at the product side is 0. So plus 2 minus 0 will give us plus 2. Will give us plus 2. Plus 2 minus 0 will give us plus 2. So let's look at that of silver. Oxidation number of Ag. Now, at the product side, we have 0. So that will be 0. Then at the reactant side, we have 1. So that's 0 minus plus 1, which is equal to 0 plus times minus will give us minus 1. So which is equal to minus 1. Which is equal to minus 1. Now, at this side we have plus 2. At this side we have minus 1. That is magnesium equal to plus 2. Then the silver equal to minus 1. So let's equalize the number of, the next stage now is to equalize the number of electron loss and to equalize the number of electron gain. Then don't forget that those one with positive, the positive ion, they do give out what? Electron. So which leads to what? Loss of electron. Now those one with positive ion, they give out electron, which leads to what? Loss of electron. While those one with negative ions, they accept electron towards themselves, which leads to what? Gaining of electron, which leads to gaining of electron. Now therefore, this one will give out, this is positive ion, it is a giver, so it will give out electron to this negative ion. So we have to equalize the number of electron at both sides. So this one is plus 2. We equalize this one to be what? Minus 2, because the number of electron loss must be equal to the number of electron gain. So the number of electron gain, the number of electron loss here is plus 2. So the number of electron gain must also be equal to minus 2. Don't forget that those ones that what? That gain electron, they are negatively charged. those one that accept electron are negatively charged. So the negative will gain electron. So while the positive will what? We lose electron. So loss of electron is positive, while gaining of electron is what? Is negative. Then we equalize the number of electron gain and loss. Now, therefore, this one is 2. This one must also be equal to 2. I will multiply this one by 2. So which is equal to minus 2. So since I've multiplied this by 2, I have to multiply my silver from this chemical what? Reaction. I have to multiply Ag from this reaction by 2. I multiply this what? The number of electron what? Gain by 2. So I must multiply my silver here from this equation by 2. So my equation will now be Mg plus, you multiply 2 by Ag to give me 2 Ag plus, because I've multiplied the number of electron by 2. So equal to, then Mg, don't forget that we are only what? We are only multiplying Ag by 2. We are only multiplying Ag by 2. So 2 plus, multiply this 2 by what? By Ag at this side. So we give you 2 Ag. So let's check the number of electrons at both sides. Let's calculate the number of electrons at both sides. Now, what is the oxidation number of magnesium? That is 0. Then plus, the oxidation number of silver is plus 2. Plus 2 times 2 will give me 2. Plus 1 times 2 will give me 2. Then equal to, let's check at this side. The charge of magnesium is plus 2 times coefficient, that is what? Plus 2. Then the oxidation number of Ag is 0, because this is a free atom. So it's 0 times 2 will give me 0. So therefore we have plus 2 at this side, plus 2 at this side. So our equation is balanced. So this is our product now. This is our product. This is our product. This is the final product. This is the final product. So we have come to the end of this class. In my next video, I'm going to explain balancing of complex ionic reaction. Balancing of complex ionic reaction. If you are new here, kindly subscribe to Royal Learning channel to have access to my past videos.